Hi friends, you're welcome back to my channel. In this lesson, I'm going to be walking you through very quickly subject formula. So what I have here is these three questions and it says, make the following letters the subject of the relation. And the letters I mean, in the first one, I have V equal to U plus AT. So make A the subject of the formula. In the second one, I have that V squared equal to U squared plus 2AS semicolon S, meaning make S the subject of the formula. Then finally, the third one that says S is equal to UT plus half AT squared semicolon A and T, meaning make A and T the subject of the formula. So very quickly solution, let's start with the very first one, which says V is equal to U plus AT. So we are told to make A the subject of the formula. So how do I do that? Very simple. Um, I am going to subtract U from both sides. By subtracting u from both sides, it simply means carry this u to the other side of the equation. And in mathematics, whenever we carry something from one side of the equation to the other side of the equation, it will obviously or always attract a change of sign. That is, if the sign is plus, it will change to minus, and vice versa. So here I have plus u, it will cross to the other side of the equation, it will change to minus u. Hence, I will have v minus u is equal to at, and this is it. The next step now is to divide both sides by that variable that is attached to t, sorry, that is attached to a, in order to make a to stand alone. Now I have 80 on the right side of the equation, so I'm going to divide both sides by t such that a will stand alone. So dividing both sides by t, I will have that v minus u all over t is equal to at all over t. This is it, dividing both sides by t. In this case, I will cancel t, will cancel t off, and only a will be standing. So finally, v minus u all over t is equal to a. Now I've ended up making a the subject of the formula. Why do I say so? Because only a is standing alone. Now remember, this is the question, this is the answer. In this question, we are told to make a. Or why is it possible that we can make a the subject of the formula? That is because a is not the subject of the formula, or only A is not standing alone on one side of the equation. But in this original question, the subject formula here is V because it is only V that is the subject of the formula. So we've ended up making only A to stand alone on one side of the equation. Hence A is the subject of the formula. And now, even from this very answer we have, we can still be told to make V the subject of the formula. And if we do that, we are going to get back to this as the answer. Alright, so this is it for the first question. Then the second one, we have that V squared equal to U squared plus 2AS. We are going to make S the subject of the formula. So let's quickly run through. V squared is equal to U squared plus 2AS. Making S the subject formula, we just need to carry U squared to the other side of the equation. And when we do that, V squared minus U squared is equal to 2AX. We have this. Now, next thing to be done here is simply to divide both sides by that which will make S to stand alone. And that is nothing but 2A. So if I divide both sides by 2A, S will end up standing alone. Hence, V squared minus U squared all over 2A is equal to 2AX all over 2A. Then 2A down here will cancel out 2A off, and when that happens, S stands alone. Therefore, V squared minus U squared all over 2a is equal to 2. Sorry, is equal to x. And I have this as my answer. Then finally, let's quickly bury the last one. The last one says that x is equal to ut plus half at squared. We are told in this last one to make a and t the subject of the formula. So we're going to do that individually. So let us start with, or let us start by making a the subject formula first. First of all, we're going to carry this ut to the other side of the equation. And when we do that, we have that s minus ut is equal to half at squared. Alright? So, but I want you to know that this that I have like this can as well be written this way: s minus ut is equal to at squared over 2. Mathematically correct. So don't forget that at this stage we want to make A the subject of the formula. So the first thing to be done here now is to cross multiply. But before we cross multiply, I want you to know that this thing is same thing as saying this over 1. So we are still correct. Because anything divided by 1 is equal to that same thing, alright? So now I can cross multiply. Cross multiplying simply means that this at squared will multiply 1 and this 2 we have to multiply x minus ut. When that happens, I will have at squared is equal to 2 into x minus ut. I have this. Alright, that is 80 squared times 1, I have this. Then 2 times this, I have this. Alright, now how do I now finally make a the subject of the formula? By simply dividing both sides of this equation by t squared. And when I do that, I'll have that at squared all over t squared is equal to 2 into x minus ut all over t squared. So t squared here cancels t squared here. I will have a is equal to 2 into x minus ut all over t squared, and that's it. So this is the answer of this very question when a is made the subject of the formula. Now, let me quickly wipe this part. Please take note of this part. I'm going to wipe it very quickly so that I can make t the subject of the formula. All right, still on this same question. S is equal to u t plus half a t squared. Hence, now I'm going to make t the subject of the formula. Making t the subject of the formula, there is something I'm going to do to this equation. First, now let me tell you something. To make a variable the subject of a formula in a particular equation, what it means is that after making that variable the subject, we should no longer find that variable on both sides of the equation again. For instance, remember this one now. When I made a the subject of the formula here, I have this as the answer. Now it means that a is standing alone on one side, and I will no longer find a on the other side. So any variable you make the subject of the formula must no longer appear on both sides of the equation. It must appear on one side of the equation alone, and it must be standing alone. All right. So now, and if I follow now, there's a part. If I try to follow the part I've already taught here, it may not really work here. So what I'm going to do to this very question is simply to rearrange it in the order of a quadratic equation and compare it with the general form of a quadratic equation. Meanwhile, the general form of a quadratic equation is that ax squared plus bx plus c is equal to 0. So this is the general form of a quadratic equation. And of course, knowledge of quadratic equation makes us know that from completing the square method, because when we have this, we can run through completing the square method and get the general formula of a quadratic equation, which is called the almighty formula. And that formula is gotten by making x the subject of the formula from the general form of a quadratic equation. And when we do that, we have that x is equal to minus b plus or minus square root of b squared minus 4ac now all over 2a. Very important. So if this is a quadratic equation, this is the subject formula, or this is the answer when x is made subject formula. Alright, so this is a general form of a quadratic equation, and in making x the subject of the formula in this general form of a quadratic equation, this is what we have as our answer. So where am I trying to get to? I'm trying to tell us here that we can make this equation here to be in this form so that we can finally make the subject of the formula and the answer will look somewhat like this. Now, according to this general form of a quadratic equation, I want us to know that this is A, this is B, this is C. Now, let me just put this in this form. So if I do that, I will have that this is 1 over 2, that is half AT squared plus ut minus x is equal to 0. That is, every other thing, this one is already on it. So trying to comparing, making this to be in this form, I will have this. That's half at squared plus ut minus s is equal to 0. So now I may call this equation 1, I will call this equation 2. Now, next thing I'm going to do now is to compare equation 1 and equation 2. So, comparing equation 1 and equation 2, I will have that A is equal to half A. Very important. And x squared is equal to t squared. B is equal to u. Then s is equal to t. S is equal to t. C is equal to minus x. C is equal to minus x. Of course, 0 is equal to 0. So, comparing equation 1 and equation 2, I'm going to have these parameters. Now, I am going to now substitute all of this side of this parameter into this equation, all right, or into this formula. So, here, x is equal to, so instead of writing x, I will write, because s is t. So, t is equal to minus b. B is what? B is u. So, minus u plus or minus square root of b squared, and b is still u, so I have u squared minus 4ac. 4 here, then a is already half, that is 4 times half a times a. Now c is what now? C is minus s, into minus s, close bracket. Now all over 2a. A is what? 1 over 2a. A is also half a times 1 over 2a. Now I am done with the substitution, so I can now do some mathematical, I can do some simplification just to get my final answer. So here 2 can cancel 2, and 2 cancel itself, 1 cancel 4, 2. I have that. So t is equal to minus u plus or minus square root of u squared minus. Now, this is minus here, this is minus in here. So, minus times minus is already plus. So, plus. Now, 2 times a, 2a all over a. And that is the answer. Now, from this, if x is equal to ut plus half at squared, making t the subject of the formula is this. Now, notice that t is now equal to this, the whole of this as the answer, when made the subject of the formula. Because on this side of the equation now, I no longer find t or t squared. So that is the answer to this question. So feel free to like my video, share, comment, and of course, give us a thumbs up. Thank you.